Everyone, we're going to continue with our videos in the introduction to statistics, and here we're going to talk about tests of hypothesis concerning means. In particular, in this video, we're going to discuss t-test for dependent samples. Okay, so previously we have talked about t-test for independent samples, and in that kind of t-test, it was used to compare two sample means when the samples were independent. Here, a different version of the t-test will be explained. This version is used when the samples are dependent. That is to say, we can say that it's dependent when they are related to each other. Some would use the words paired or matched. Okay, so that's when we say that two samples are dependent. So one example that I can illustrate is, suppose a medical researcher wants to see whether a vaccine will affect the reaction time of its users. So to test this hypothesis, a researcher must first pre-test the participants in the samples. Okay, that is, we need to measure or give a test to ascertain their normal reaction times even before the vaccine is already administered to them, before the vaccine is administered to them. Then, after that pre-test, that's the vaccine, that's the time that the vaccine will be used or will be applied. The participants then are tested again using now a post-test. Finally, the means of the two tests, pre-test and post-test, will be compared to see whether there is a significant difference between the pre-test and post-test. Since the same participants are used in these cases, what we will use are, we can say rather, the samples are now related. So participants scoring high in the pre-test will generally score high on the post-test, even after the vaccine. And likewise, participants scoring lower on the pre-test will tend to score lower on the post-test. To take this effect into account, the researcher employs a t-test using the differences between the pretest and the post-test values. Thus, only a gain or loss in values is compared. And that particular t-test, as we know, there are different types of t-tests. We will make use of the t-test for dependent samples. Remember that these kind of t-test is used for, obviously, for dependent samples. This is a special kind of t-test for dependent samples. It's used when they're dependent, when they are matched, when they are paired. Some books would like to call this paired t-test, and take note they're the same. This test employs the difference in values of matched pairs. So the hypothesis may be stated as follows. It may be written as, here for the null hypothesis, your mu sub d, which is the mean of the difference, is equal to 0. That is, there's no difference, and the status quo is observed. For the alternative hypothesis, we will consider three cases. If it is two-tailed, we're going to make use of this. The difference is not equal to 0. If it's left-tailed, this one, and right-tailed, this one. I think it's obvious by looking at the inequality. You can see the direction of the test. Note that mu sub d is equal to the first mean minus second mean. The d stands for the difference, okay, or the symbol itself stands for the population mean of the difference between the two measures of each subject. So the formula is as follows. Here it is. So T is equal to D bar, wherein D bar means a mean of differences, wherein you have each D sub I is equal to X sub 2 minus X sub 1. You're going to get the mean of all of that, divided by S sub D, which is the standard deviation of the differences, and the N will be the number of pairs, and then DF will be equal to N minus 1, which is the degrees of freedom. Now, what we're going to make use, or what we're going to do to solve the t-test of dependent samples, making use of this video, is we're going to make use of the approach called the p-value approach, which makes things easier making use of a statistical software. In particular, the software that we're going to use is the Jamovi. So for the p-value, remember our decision rule for the p-value is as simple as this. So if the p-value is less than or equal to alpha, then we reject the null. If the p-value is greater than alpha, then we do not reject the null, or we fail to reject the null. So to put that all in perspective of procedure or steps, we have these steps. So recall, number one is we need to state the hypotheses and select the level of significance alpha. Number two, select the test statistic or the appropriate statistical tool to compute um, to compute, and then after that, compute the p-value. And the number three, the decision rule, it will be the one that I have just said before. And then number four will be making the conclusion. So let's cite one example here. Say we are asked to we're asked the question, does therapy reduce anxiety for those people who have this tendency to have anxiety? So if ever you will put some therapy here, will it reduce anxiety given the following data below? And we're going to test that at alpha 0.05 or 5%. Okay, so we're going to make use of the four-step procedure in order for this to be procedural and in the correct process. So let's write first the hypotheses. So we want to ask if therapy decreases anxiety. So the null hypothesis will say that there's no or there's none. There's no significant difference, meaning that it's the same. So you can say that your mu sub t is equal to 0, or there's no significant difference in the mean anxiety levels before and after the therapy. The anxiety levels before and after therapy are the same. It can be also stated as that. Your alternative one is that your mu is less than 0, or the mean anxiety level after the therapy is lower than the mean. Take note, this is one-tailed test because the question itself asks if the therapy reduces anxiety. Only reduces, okay? Strictly reduces. So that will be one-tailed test, specifically left-tailed test. And the alpha is 0.05, which is given. Now, given this scenario of the data before and after, so again, before the actual therapy, the researcher measured their anxiety level, and then you do the therapy, and then after you measure it again. So the question is, is there a significant difference? Does therapy indeed less, reduces the uh, the anxiety level of these five patients? So since the samples are paired, hence we will use the t-test of dependent samples or paired t-test. So for step two, we're gonna make use of Jamovi here. Now let me shift to Jamovi right now. So what we have here is Jamovi. So I tried to fit it in the screen. So I have already put the five patients. So we have patient 1, 2, 3, 4, 5, and then we have the scores before and after. What we're going to do is we're going to go to Analysis tab and go to t-tests, and we want to make use of paired samples t-test. And we will be given this window then. What are the pairs that we want to match? That's the question here. So I want to match before and after, and then it will appear on the right side of the screen, whatever you did. So we have there p is equal to 0.038. But that's not enough yet, because remember our alternative hypothesis says that it's one-tailed, specifically one-tailed left. So we want to put it here right like this, or rather, it should be written like this. Okay, why this? Because we want to show that the measure of the therapy reduces anxiety. So it should be that your measure two should be less than your measure one, because it decreases it. Remember, your measure two is your after, so it should be decreased. Okay, so meaning rather it's the one less than, because we want to show that before the anxiety levels are high, and after the anxiety after the therapy, the anxiety levels are low. So, and then we want to put it there, and what we have over here are the results. Let me make it bigger. Okay, here. So for the paired samples t-test, we can see that before and after, your measure, the difference is greater than 0, meaning there is a difference. Or rather, the measure 2 decreases, right? So we have statistic is 3.048, the DF is 4, and your p-value is 0.019. 0.019 is clearly less than 0.05. Let's go back to Excel, and I will just transfer what Jamovi gave us, which is actually this one. and note that it's 0.019. With that in mind, we can now put into the decision rule. Remember that our p-value is equal to 0.019. You can write it as this, which is less than our alpha level, which is 0.05. If that's the case, hence we will reject the null hypothesis at the 0.05 level of significance because a p-value is less than the alpha level. If that's the case, we can conclude now. We go back to our hypothesis, and since we will reject the null hypothesis, we will follow the alternative one. And then we can say that therefore the mean anxiety level after the therapy is lower than that of the mean anxiety level before the therapy at 0.05 level of significance. That is, the therapy significantly reduces anxiety among the patients at alpha 0.05. So that's the essence of it. That's how you basically do a dependent samples t-test, or a t-test of dependent samples, or a pair t-test, whatever you want to call it, making use of Jamovi. Okay, so hopefully you got that. If you haven't yet, you can always, try to do this again on your own. Practice, because without practicing, you will never really learn this. So practice. Okay, so thank you very much. That's it for today. See you next time. Bye.